Today, we're going to be looking at CockroachDB Cloud's standard tier and why we recommend it for most production workloads. If you're planning on self-hosting a multi-region CockroachDB cluster, you'll need to know how many nodes you'll need in each of those regions. Whereas CockroachDB Cloud's standard tier offers you a number of vCPUs to use across the cluster. So if one region is busier than the rest at any given time, that region will receive more vCPUs. And as usage patterns across the cluster and regions change throughout the day, so too will the distribution of vCPUs. So the only thing you need to think about when provisioning a standard tier cluster is how many vCPUs do I need during my busiest times. Let me show you what I mean. In this demo, I'll run a multi-region cluster across Virginia, Frankfurt, and Singapore, all running across different time zones. So at 3 AM Virginia time, hardly anyone's online and CPU is very low, whereas in Frankfurt it's 8 AM and people are starting their working day. So usage is ramping up. Let's say in Frankfurt at this time, we'll require about 2 vCPUs to handle that load. Whereas in Singapore, maybe we've got a smaller number of people using the application in Singapore, but we're at 4 PM, so still within the busiest period. In total, the 2 vCPUs required for Frankfurt and the 2 vCPUs required for Singapore total 4 vCPUs to handle that workload. Let's fast forward a bit. And now we're at midnight Singapore. Usage has tailed off, but now we're in the busiest periods for Virginia and Frankfurt. To handle the higher load in Frankfurt, let's say we need 4 vCPUs, whereas for peak time in Virginia, we need 6 vCPUs, a total of 10 vCPUs. Fast forward again, and now we're at 4 PM Virginia time, so still within their busy period. We still need 6 vCPUs, but both Frankfurt and Singapore are offline, requiring very little in the way of CPUs. So for this period of time, we need 6 vCPUs. The busiest time we needed to satisfy all workload globally across the cluster was 10 vCPUs. So that's my calculation for this cluster, and that can be graphed. What we're seeing here is load in Singapore and load ramping up in Frankfurt as the day is starting to end in Singapore. So there's an overlap here, and there's a period where both Frankfurt and Virginia are online, and that overlap can be seen here. Adding together, we're left with this. The total amount of vCPUs at those 2 peaks is what our cluster will need to satisfy. Let's spin up a cluster now, and you'll see what I mean. I'll create my cluster running across Virginia, Frankfurt, and Singapore, and I'll provision 16 vCPUs for this workload. And I'll set some environment variables from the response. I'll generate a random password for the user I'll create in a second. This is the URL of the global CockroachDB load balancer that each of the users across the world will consume. And once the cluster's ready, I'll create the user. That's now created. So with this command, I'll create a user called Rob, whose password will be the password I generated earlier. And I'll test my connection to CockroachDB. I'll now run a script to set the default DB's primary region, which may or may not match the cluster's primary region, and add the other 2 regions so the database is aware of them. I'll create a simple table that will allow me to simulate bank account activity. I'll make sure it's empty, and I'll insert 3,000 rows, 1,000 for US customers, 1,000 for European customers, and 1,000 for Singaporean customers. And with the table and data in place, I'll now run a workload. Now this workload will simulate exactly what we saw in the charts. Usage will ramp up across the day, across each of the 3 locations, so we can see what the CPU usage looks like in CockroachDB as a whole. I'll deploy my workload, providing the global URL that will serve as the connection string for the applications, and then I'll deploy 1 instance in Virginia, 1 instance in Frankfurt, and 1 instance in Singapore. Once the application is published and running, we'll start to see logs here. And I'll also track the CPU percent in CockroachDB, so you can see what that usage pattern looks like. For every 2.5 minutes that elapses in the real world, I'm simulating 1 hour of usage in each of the 3 locations. So over the course of 1 real hour, 24 hours would have elapsed. The application is now deployed, so let's have a look at these logs coming through. In Frankfurt, I'm simulating 11 AM, and because we're in the middle of their busy period, I'm simulating 500 requests per second. In Virginia, it's 5 AM, so I'm simulating around 10 requests a second to show that there's hardly anything happening. And the same in Singapore. It's 6 PM, so I'm simulating the tail off of requests. So the cluster isn't very busy at the moment, but that will change as Virginia comes online. Let's refresh the CPU graph here. And there's our uptick in CPU. I'll come back in an hour and we'll see what the CPU graph has been doing over that time. Just jumping back in for a minute, we're about 10 to 15 minutes later now, and we can see that if I pause the display, both Virginia and Frankfurt are now in their busiest operating periods, and that can be seen from the uptick in requests to CockroachDB. We're now 1 hour into the workload, and if we have a look at CockroachDB, we'll see that there were busy periods when both Frankfurt and Singapore were in their peak business hours, and then peaks as both Frankfurt and Virginia were in their peak business hours, and we're now returning to the peak of Frankfurt and Singapore business. So 24 hours of simulated workload. Most importantly, we can see that the CPU never spikes above a certain threshold, and that's because we've provisioned the CPU for the maximum estimated usage across the cluster globally. CockroachDB ensures there's CPU where CPU is needed, and in so doing, it's removed the maintenance burden from me. Unless you want to self-host CockroachDB yourself or have dedicated hardware, the standard tier is perfect for most production workloads, allowing you to run one global database without having to worry about resourcing for each region. Give it a try and see how it could benefit your workloads.